Good morning, Ivansu.
Good morning, sir.
Okay. Today it will take 5 to 10 minutes, right? So what are the 10 minutes?
Sir, your audio is not clear, sir. Hello.
Okay, is it audible now?
Yes, sir. Now it's clear.
Okay.
Okay, so good morning to everybody. Is it
Good morning,
audible
sir.
clearly? Okay,
Good morning, sir.
good morning. And today we are going to start. I think this is the first lecture of this semester, right?
Yes.
Okay, so I am Dr. Samir Trapasya and I am the faculty of the GCET department. I joined the GCET since 2007, right? So I'm working here over the last 13 years. And within those 13 years, most of the times I have came across the various wireless communication subjects like the wireless communication, digital communication, analog communication, and the signal and system. So I basically working in the core branch, core subject of electronics and communication regarding the wireless communication, digital communication, etc. And my research domain is also in the same direction of wireless communication. So we are going to start the journey of the signal and system from here, and this is the first subject in this chain. So chain is actually built up of core communication subject, and this chain, the beginning of the chain is basically start from this subject, signal and system, right? Then it will be led by the new subject, analog and digital communication. Then it will be led by the wireless communication. So all these three subjects you have to learn in a consecutive semester. The basic and fundamental blocks of this whole communication subject is the signal and system. So it's a very interesting subject. So you will learn many new things over here. And we have a 3 lectures in a week. So I assume if everything is going in a planned manner, and if we have a very less amount of the holidays in between and so on, so that at least we are able to take the 35 to 36 lecture, and that is a good amount of lecture for any subjects which is of a which has only 3 lectures in a week. And I hope see, teaching and learning is basically bi-directional process. So from my side, if I give the 100%, if I put the 100%, but if you are not putting your heart over there, then it will be not be completely fulfilled. So I urge you, I request you to that same things will should be happens from your side also. If I'm going to put 100% from my side, and if you are not you also have to put the 100% from your side, and then this closed loop will be performed, and then we can have a very good teaching and learning environment in this subject, right? So I'm sure that whatever the efforts that I'm putting in this subject, the same efforts you are putting of this subject also. And I will make you sure that you this signal and system will you can have a best experience of signal and system at the end of the semester, right? And don't worry, because you are learning the signal and system from the best faculty of the GCTC department, right? So we have a number of years of experience, and that whatever the knowledge I have gained over this, that I will be share with you in this subject. So this subjects will be going in a right direction in a fruitful manner, and I'm very punctual to take the lecture. So there are very rare probability I miss the lecture in somehow within the semester. So the same regularity I am also expecting from you. This subject can be learned only if you are regular, because if you start something, some chapter has been start in some day, and you will make a bunk between in the next second and third day, then it will be not the complete fulfillment of the subjects will not be done, and you will lose most of the contents, right? And then you again attain after some break, then you are not going to connect with the subjects, the content of the subjects, and that the flow, whatever the flow of the subjects may not be completely conveyed to you. So it is very necessary that with whatever the energy, enthusiasm, and regularity I am teaching, the same enthusiasm and regularity is also expecting from your side also, right? And hope you are now with a full of energy, and with a fresh perspective to learn. And with this fresh perspective of the learns will be very helpful. Energy and fresh perspective to learning will be definitely will be helpful to learn these subjects as its fullest, right? These subjects will be conveyed to the fullest. And if you compare the teaching of this subject with other institutes, so you will find the notified difference over there also, right? So I will make you assure that if you support me, and whatever the flow I am going to generate, whatever the things in my mind to deliver you with the same intensity, if you attend the lectures, and if you joined with me, if you connect with me with the subject, then definitely you will get the full benefit of this subject, right? Okay, so now I'm going to start my screen, sharing my screen with you. And today, basically, we will discuss about the what is the main objective of this subject, why this subject has been a part of your curriculum, what are the advantages to learn these subjects, what are the benefits that we need to be shared with this subject, and how this subject is useful to build up a strong foundation for the subjects which is coming in the next semester, like as analog and digital communication and wireless communication, right? So I will try to connect you this subject with some advanced subjects that you have to learn in the coming semester. And meanwhile, if you have any doubt, so basically the doubt generally will be addressed at the end of a section, at the end of section. So at the end of sections, we can have a spare of 5 to 10 minutes. Within those 5 to 10 minutes, if you can have any doubts, then we will discuss about the doubts and all this query you solve the query over there. So this 5 to 10 minutes is basically dedicated for the questions answer. And if you have any doubts regarding the lectures, then we will briefly discuss about this. All the questions will be welcome from you. I am eager that to hear a questions from your side, right? To reply the questions, I am very enthusiastic to reply the questions, because if you don't have a questions, they have only two meanings. The one meaning is that you have completely learned whatever is going to deliver through this platform, and the second thing is that you don't learn anything, right? So but you should not have to fall in between. If you learn anything, whatever I'm teaching over here, if you learn everything, that you definitely have no questions. But it is a very optimum situations, right? And most of the times this will not be fulfilled. So the second thing is, if you don't understand anything, that again you don't have a question. So this is our scenario that we will not we cannot have like this scenario where you don't understand anything, right? We want to break this barrier. So definitely you are somewhere in between, where you understand some things and you want to learn something new, you want to dig up something new. And to support this system, the question and answering is very basic tool to learn something new. So I openly welcome you for any kind of a questions, maybe a silly questions. There is nothing the questions like the silly questions. All the peoples are standing at the different level of their life, and or the same way in subject teaching, every peoples are standing at the different level of understanding. So if you are asking some questions from some level, so some people who are above these levels may consider it as silly questions, right? But for a teacher, no any question is a silly questions, but the main role of a teacher is to boost up your knowledge, to bring up a new things in front of you, so you can learn something new and your fundamental concepts becomes clear each and every iterations of a teaching. So that means if you are asking questions, so it may be a silly questions from some other's mind, but not in the minds of a teacher. So from my mind, no any question is a silly question. So all are just the steps to move further. So that way we are going. So I'm very generous to sharing my material with you also, because I believe the sharing the materials will help you to understand the fundamental concepts further. So whatever the my notes available with me, and whatever the notes will be created during the few lectures, that I will generously share with you. And that is your part, that is your duty also. Whatever the materials that you prepare, that you also share with your classmate. Whatever the assignments are, I am sharing over here, and make this, consider that one as a learning opportunity. Because if it's like as an example of a cycle, right? How the teaching and learning is basically focused. So if you see, if someone want to learn the cycle, right? If you remember your old days of your childhood days, when you have started to learn the cycles, so how you have learned the cycles? You have started the learn the cycles, then there may be many times you fall on the ground, right? Or you injured also sometimes. But that way you learn many new good factors, right? How to concentrate it on the way in the front of you, and how to concentrate it on the pedals which is running over there, and how to synchronize both the things, right? So then you learn the cycle. So after 5 to 7 days you becomes you learn the cycles completely, right? So in this process, why you now, the question is how you learn the cycle. So there might be one short answer is that you have to do it by yourself, right? So assignment is the same opportunity. Assignment is the opportunity where you try to do something by your own self, right? Whatever you are learning over here, and when you implement this, you have some thoughts in your mind, how the thoughts are implemented. So some problems and assignments are the places where you apply your thoughts, and that way you are learning, right? Now what is the role of teacher? So if you learn the cycle by yourself, you take the 7 days, right? And you have been passed through many injuries, and many times you fall on the ground. But now if some teachers or guide are available, then they will teach you the same thing within a 3 to 4 days, right? So two things will be saved. You have a less injury, right? And the second thing, your time will be saved. The same role is a teacher. So now here we are. Why we are here? Because we are here to make your work easy, and to and when you start to learn something by your own self, you are not connecting with the world. You don't know what is the importance and significance of the subject. So now the role of a teacher is to amplify their efforts in some way, so that whatever you are learning, how this is important, what is the significance of learning in the futures. So to realize the students the same similar kinds of things, right? To realize the students that whatever you are learning, they have a great impact in a later stage, and to connect those things with the real world scenario and real world problem. So that's why we are here, to make your work easy. And so whatever the materials and everything, I will generously share with you, and the same parts from your side also. Whatever the assignments I will giving you, with a fully heart and with dedicated efforts, you need to complete those assignments by your own selves, right? And now we are going to start this sessions. I'm going to share my screen with you, and in this screens we are discussing what this subject basically is, what is the application of this subject, and what is the micro level planning of this subject, what is the course content of the subjects, which are the books that you need to follow throughout the semester, which one is the best book or reference book that you need to consider for your whole subject, and what is the list of experiments what we are going to do in a practical sessions. Because whatever we are learning in a theoretical sessions, that is good, but finally the mind is actually more convinced whenever something is visualized, rather than it will be delivered only in a some words, right? So words, rather than words, the picture creates a more, it's a 10,000 more times, it's create gives your fundamental concepts clear. So that is very important, that you need is visualize some things. And practical is also gives you opportunity to do something by your own self. So practical is basically the implementation of theoretical foundation that we have laid down in the class, and it will be helpful for the students to learn something by their own self, and to verify the things whatever we have learned in the theory. So that way the practical sessions would be definitely remains very fruitful, and we will even discuss about what are the list of practicals that we have defined for the subjects throughout the semester. Okay, so I think you are very much, I means you are flourished with the positive energy to learn this subject. And now we are going to start this subject. I'm going to share my screen with you. Meanwhile, if you are not getting anything clear, or my audio may not be clear somehow, so you will let me know, so I can manage my microphone and all the things. So then it may be later becomes a clear.
No, sir, you're clearly audible.
Okay. Okay. Now the screen is clearly visible to you. Is this screen clearly visible? The blank page, I think, has
Yes,
been.
sir.
I have.
Yes, the blank page is
Yes,
visible.
sir. Yes, sir.
Yes. Okay. So this subject is basically defined as a signal and system, right? And the code of this subject is 3141005. So if you look around, there are two words of very which make this subject's whole line of this subject, title of this subject is a signal. This is the one. If you compose these two terms, signal and systems, right? Uh, then it would be the title of your subject. So there are two things that you have to learn. One is the signal, and another is a system, right? So basically if we go with a very layman way, then we will consider the signal is basically whatever the pictures in your mind. If I talk about the signal, so something comes in your mind and definitely it is the sinusoidal signal, right? So something comes in your mind as a sinusoidal signal. Not necessary this is only the signal. They may have many signals like as a ramp signals, many arbitrary signals which you cannot be defined in form of a mathematical model, that are also signal. But this is a signal where the x-axis just represent the time, so it can be represented by the variable t, and y-axis represent the amplitude, so it can be represented by some magnitude, and if it has some maximum peak value Vp and it has some negative peak value, that is known as a minus Vp. So this way we can define any signal. But how you plot this graph? So to plot this graph, what this graph is basically, this graph is mathematically written as a sine omega 0 t. We simply write omega 0 t, where omega 0 is the frequency of signal and t is the time of the signal. Now to plot this graph, this one is known as a graphical presentation of this one. And if we talk about some mathematical presentation, so we can have, see, this gt of sine omega 0 t is nothing else but this one is known as a mathematical presentation, right? And if I represent everything in form of a table, so I can say that this one is my time, and the second column is known as a sine omega 0 t, right? This is a function. So this one sine omega 0 t is a function and t is a variable, right? So different value, if we assume omega 0 is something 2 into pi into 10, right? It has so many arbitrary value if you choose. So it is of a frequency of 10 hertz. So in radians it can be represented as a 2 pi f, so f is equal to 10 here. And if you put the different value of a point 1, point 2, up to 1, 1.1, and up to 3, etc., so you are getting the different value of sine omega 0 t, starting from point 3, then it attains the 5 volt, then you can have a point 3 and minus 5, right? So this is the what the values of the of your function, and that is simple known as a data. This is the data, right? And if I plot this data over here, so I can have this kind of a graph. So every value of t, if I choose the different value of sine omega 0 t, then you can have a similar kind of graph, like as you may have a point 1 and here you may have a point 3, and for every value of t you may have a different value. And if you join down those all the values which is over here, if you join down all this point, right, here there may be some points over here, then you can have a complete graph. So if this graph is basically not a signal, this comes from a data, right? So if you have a data, then you can have a graph, and if you have a graph, then you consider it as a signal. So basically signal is comes from a data, right? So with this data will represent a signal. So signal is what is now the definition of signal. So now we can lay down the definition of signal is as a signal is nothing else but it is the collection of data. If you have a data you are collecting, then you can have a signal. Now I can give you one more examples. In Vallabh Vidyanagar, if you have a temperature recorder, right? If you have a temperature recorder, and especially this temperature record is basically used to find the weather condition, to measure the weather condition in Vidyanagar throughout the year. So if you have a data like this, you can measure the average temperature of a day, right? Every day. So we can start with the first date, 1st January 2020, and then every day you measure some you continuously measure the temperature, but you find the average value of the temperature for a day, right? And that you will repeat for the last date would be 31st December, so that you continuously record those temperature, right? So this is the date, this one is the date of a temperature. And if you can have a temperature over here, it's starting from a 20 degree to, if you are moving in some way 25 degrees somewhere in a month of May, you have a 45 degree, etc. And if you plot this graph of temperature on x-axis, and that sorry time, so it's a time on x-axis and the temperature on y-axis, right? So temperature. And here, if you start with the first January to the 31st December of the year, then every times you have a new points are there, you have a different points are there, right? These are the points. This is the points at which is the value of the temperature which is recorded at the 1st January. This will be the temperature which has been recorded with some other date, like as a 2nd February, and you have multiple points are there. And if you join down this all these points, if you join down all these points of temperature recorded for each date, for every for all the 365 days, and so you have a 365 points, and if you join down this, so this what is created over here, this is the signal. But basically the signal is coming from a data. If you have a data, then you plot the data with respect to one variable, and then you have a complete graphs. Graph is just a visualized presentation of data. Graph is nothing, it's a visualized presentation of data. And graph will be formed out, but prior the graph we should have a data. If we have data, then we can plot the graph. So very importantly that we can consider, if you have a data, you can plot the graph. So signal is basically nothing else, but it is the collection of your data. It's a collection of your data. And now if this data I will give I will the same data I will give to the one program, right? One program you have written, in which we need to identify how much temperature rise in every month, right? How much temperature rise, or we give this data to some entities. In this entities will give us the maximum value of temperature per day, right? Maximum value of temperature in a year or per day. So what you do, give this data. This data is suppose recorded in a set of S, right? All this data, all the temperature data recorded in a set of S, starting from 1st January 30 25 degree and all up to the last. So what is the size of this matrix? 1 cross 365, one row and 365 columns, because you are recording the temperature for every day, average temperature of every day, right? Average temperature of every day you are recording and store in S. So if the S is given over here, then it will be gives the Z, right? Let's say maximum temperature of the year if you want to consider. So maximum temperature is found as a 45 degree. So what happens over here? This is the entity in which the data is processed. This is the entity in which the data is processed. And after the processing of data, we came across the some outcome. So this one is the input. This is a set of inputs. And at the output, either we can have a single output or sometime we can have a set of outputs, right? So set of input is applied to some entities. This entity has processed your data, and after processing we can have a some output. Now this entity may be your computer, maybe your laptop, maybe your Raspberry Pi, maybe your Arduino processor, anything like this. But after processing your data within this entities, you have obtained one outcome, and this entities which process the data to generate the some new outcome, this entities it itself is known as a system. It is known as a system. So now this word, two words are now clear. Signal and system is basically composed of a two words. The one word is the signal. Signal is a collection of data, and the system is an entity which process on the data, right? So if we lay down the definitions of a system, so we can say the system it is a entity which process on the set of input data and generate new set of output data. So this is known as a system. Now we in these subjects we came across various kind of signals, and various kind of systems. Every signals have their own properties that we need to highlight, and every system has also some different properties that also we need to understand. So basically in this subjects we learn about the various kind of systems, various kind of signals and all this, and how, what are the processing, how they are processed, what are the basic fundamental mathematical functions that we need to implement to process those data. We even learn about these things, right? uh, this is it's a very signal and system is basically gives a very real kind of a scenario. Every data, if you have recorded some data of COVID-19, now we have a machine learning algorithms and all, they are also process the data, so they are also work like as a one system. So if you want to produce some outcome, so you have to train your system, you need to train your system, and before to train your system you need to understand the types of a data, right? How which kind of a data that you are collecting, what are the major factors you need to identify from this data, and accordingly you need to organize or you need to develop your system. So first of all we need to understand the types of signal, the nature of signals, and then we secondly we have to define what kind of outputs we want to obtain from this data, which kind of output is important for us. So accordingly you develop a system. So this systems will take your data as an input data and generate a new stream of output data, right? And that is all the this subjects will in this subjects we will learn about all these things, the types of signals and types of systems, the processing, what are the main processing functions that are widely used and they are adopted by most of the communication systems and all. So first of all, we are going to start with the course overview, and the today this is a first lecture. This is the detailed syllabus regarding, it's a lecture-wide detailed syllabus about the subjects of signal and system 3141005. And here the first basically there are 35 to 36 lectures have been decided over there, and there are four chapters you have to came across. There are four chapters are there, one more sorry, five chapters are there, right? So first chapter is basically about the introduction to the signal and system, in which we learn about how many types of the signals does exist, how many types of systems does exist to process those signals. So we will pass through the course overview in the today's lecture. This is just a macro planning, we can say. In a macro planning, so you can have a lecture wise schedule, and topic wise the lectures are distributed. So first we'll discuss about the course overview in the chapter of introduction to signal and system, right? We will go on about the various kind of applications of the signal and system. So it's a real time of applications of signal and systems, whatever the projects you have made earlier by using your wireless sensor. So wireless sensors like as a temperature sensor, humidity sensors, all other sensors that you have already implemented earlier, right? So in those sensors is basically what was the output of those sensors, what the sensors will provide. So sensors will record some quantity from the ambient environment, and it will be give us the log of the data. It will give us the log of data, and that is the signal, right? That is what we can say is the signal. So signal is basically coming from a various part. There are lots of applications of the signal. In a medical emergencies, the doctors require the signals because they need to identify the, they want to monitor the patients in a COVID-19 situations, or maybe some patients have a serious heart attack, or maybe some patients are suffering from a cancer statement and all this. So they requires every times the data of the body temperatures, the body conditions, the blood pressures of the temperature, etc. So these data are required for a doctor. So they have a lots of medical applications, even in a radar systems in a military. The sky is monitoring by the military to check whether any weapons has not been passed on or has not been shoot out by the enemies of other countries or not. So they even require to continuously monitor the environment to check. They even need to monitor the radar signals and all. So they also require the data in defense. So there's a lots of need to pass through this data. Even in day-to-day life, if we are using some weather stations, so they are also used to monitor the various kind of a data of environment, like as a temperature, humidity, wind speed, the rainfall possibility, and all. So they also require data. Even in agriculture, the farmers are required. If the farmers have laid down the multiple sensors in their own field, so they even continuously need to assess those data through those sensors to monitor the data, like as a the crop variations, the crop monitoring data, like as a weather condition and soil level, soil structure. All these data are even required. They need to monitor. Even if you are using a drone has a wide applications in a today generations, because the drones can be used to move the something move the weight from one place to another place. It is even used for a monitoring and surveillances purpose. So they also require to collect the data. So you find a lots of applications of signals and system. And if we see in our surrounding environment, so you will find there are lots of places where the collections of data is required, and this collection of data is itself known as a signal. So that is very important. And other important part is that if we have flood of informations, right, we need to identify what the informations are important for you and what informations are useless for us. Some informations we require very intentionally, and some information we just have to throw away. So that part will be done by the system. Systems will identify the important systems and generate the fruitful results on the basis of the inputs which has been given by the signal. So we will came across the various type of the applications from surrounding environment and our day-to-day life. Even many of the fields in which we need requires a lots of data for machine learning also, that also forms a signal. Then we pass through the basic definition of signal and system, basic elementary systems. We will learn about the how many types of signals are there, and that is simply known as a classification of signal. Then we will learn about the various operation which is performed on the signal, then the types of signal and system. And we will came across the linear time invariant systems. This is very important. Linear time invariant systems, what is the condition through which we can assess the system is a linear time invariant system, right, and their characteristic and their application. So we'll learn all these things in the chapter number 1. Then the chapter number 1 chapter number 1 is followed by the behavior of continuous time and discrete time linear time invariant system. So in the in this is chapter number 1 is totally about the signals. We will learn the various kind of signals in the chapter number 1. Where chapter number 2 is about the system. So we'll learn about the various kind of systems over there, right. We can start the various operations we can apply on the system using a system, like as a convolution is very important operations over here, and the properties of the convolution, right. So we will learn basically convolution over here, and sorry, it's a signal and system. And this chapter is the convolution operations. So we will learn about the convolution operation in this chapter, right. Okay, so this all the chapters will in which we will discuss in this all the topics of this chapters will discuss about mainly about the convolution theorem. And then it will be led by the introduction to the Fourier series and Fourier transform, right. If we have a signal in a time domain, and this time domain signal will not give us the clear picture about the various properties. So we have to see the signal, we have to visualize the signal in a frequency domain, right. So this process to convert any time domain signal into the frequency domain signal, that is frequency domain signal, that process is known as Fourier transform, or simple known as FT, where Fourier series is a representation of a periodic signals in terms of their Fourier components. So we will pass through this Fourier series and Fourier transform, and among this all the chapters, I will consider this is very important chapters, because whatever the foundations has been laid down in these chapters, that will be definitely useful for the next semester. You will learn about the analog and digital communication, and throughout the communication, the Fourier series and Fourier transforms are used. So till you are not leaving the GSET in the final year, the Fourier series and Fourier transform will remain with you. and the basic building blocks of Fourier series and Fourier transform will be built up in this semester in this subject in the chapter number 3. So it is I will spend a maximum amount of the hours for to learn to explain the Fourier series and Fourier transform, and hopefully you will take it away, and you will try to make your fundamental concepts as much clear as possible in this chapter. So Fourier series and Fourier transform will be very useful chapters for the coming semester subjects. So we can start with the Fourier series, the components of learned components of Fourier series, how to represent the Fourier series especially. Then we learn about the Fourier transform, the property of Fourier transform, and even we learn about the Laplace transform, which is basically very related with the Fourier transform, right? So Laplace transform also. And those who are learning who are preparing for a gate examination for ME, for them this chapter is also most important, because many questions will be asked in the gate examination regarding the Fourier series, Fourier transform, and Laplace transform. So it is highly valuable chapters for them, those who are preparing for the gate examination. Then if you have any kind of a systems which has a delay response, if you want to check whether the system is a stable or not, right? Stable or not means if the system response are fluctuated, it may not remain stable, but after some time, if it becomes a constant, the response becomes a constant, so this is known as a stable system, right? So whether it is not stable, so we will check whether the response of any systems is stable or not at present times, or it maybe it becomes a stable after some times. Then we have to learn about the jet transform. So jet transform will provide a very useful insight about the stability of the system. So that is also very important chapter. We will learn about the how to converse the jet transform, the properties of jet transform, inverse jet transform, and how jet transform is used to solve the different kind of a differential equations. So we will even have a look around this, how this one is used to solve the differential equations. So differential equations can be solved using this, and how it can be solved. So we came across this one also. Then very importantly, the last chapter is about the sampling and reconstruction, right? So if you have an analog signal, the signal which continuously changes amplitude over the time, this is known as an analog signal. So if we came across any signal g of t which is continuously varying over the time, which does continuously vary over the time, and its amplitude is also continuously changing, that this signal is known as an analog signal. And if we are converting this analog signal into some digital form, right? So this analog signal is now converted in form of a digital. So this is known as a to D conversion, analog to digital conversion. And for analog to digital conversion, first of all we have to sample the signal, right? So sampling is a first process. Sampling is not only the process, the first process is a sample. So there are two processes as there. One is the sampling process, and the second one is known as quantization process, that we will learn later on around regarding this all the things in detail. So whenever we anybody want to convert analog signal into digital signals, so first they need to sample the analog signals, and then they need to quantize that analog signals to get the final outcome in form of a digital signal. So in this chapters we learn about the sampling only. Quantization is not to be covered. The quantization will be covered in the next subjects of analog and digital communications that you have to learn in the 5th semester. But at this one, at this point, at this juncture, basically, we will learn how to convert the analog signal into digital signal. And for that one we need to pass through the first process is a sampling process. So the sampling is a process to convert your continuous time signal into some discrete time signal, like this discrete time signal, right? So this is continuous time signal to discrete time signal, and to do this we need to have to sample the signals. Sampling is applicable here. So this process is basically done at a transmitter side, and at the receiver side we can have a sample signal is available, and we are from this sample version. If this is our original signal, this one is the sample version of signal, and from this sample version of signal, if we are getting original signal back, g of t signal back, so this process is known as a reconstruction, right? So sampling is a process to convert your continuous time signal into discrete time signal, and the reverse process in which the discrete time signal is converted to the continuous time signal back, this process is known as a reconstruction. So sampling is a process to convert your continuous time signal into discrete time signal, and reconstruction is a process to convert your discrete time signal into continuous time signal. So we will learn about this sampling and reconstruction in this chapter with the sampling theorem, zero hold, Nyquist criteria, aliasing effect, and all, and about and reconstruction of the signal. So this is what we are going to learn in this chapter, right? Okay. Now here we came across some basic books that we need to that we have to use throughout the semester. So very important book that you can refer is, I suggest the second one, and that may be your textbook. This book is the title is Signal and System, and the author is Alan Oppenheim. You can even note down. I will share this all the materials with you, but if in meanwhile if you find something is important and you want to use that one in your future, that you need to note it down, right? So I will not instruct you to note it down. It's not compulsory. It depends from person to person. So if something you found important, you just note it down. So you note down the name of this book here is Alan Oppenheim, written by its author is Alan Oppenheim. Title of the book is Signal and Systems, right? And another author is Alan Wilsky and Nawab, and it is printed by the Printice Hall. Printice Hall is the publication unit which has published this book. This is very nice book. If you are want to further explore the concepts of a signal and system, so I would like to suggest the first book, Signal and System, which is written by the Anand Kumar, and this is from a PHI publication unit. This is also Printers Hall, and this book is also important. But first, I will suggest this book. This one is my first preference, and this one would be my second preference. Lots of examples are given in Anand Kumar. That's why I suggest you, right? Because I consider you should have both the books. If you want to learn the fundamental concepts very clearly, so this book will be helpful to understand the fundamental concepts. And if you want to explore the examples, because this subject is full of examples, so that if you want to have examples, then you will consider this book number 2, right? So book number 2 and 1 both are useful. I want to suggest you either to purchase it, or I may make it available the soft copy of the book, right? Okay, so this both the books you will refer: the Oppenheim, the Signal and System written by Oppenheim, and the Signal and System written by Anand Kumar. Okay, so this is all about the course, and now we quickly. Okay, I think this is repetition. Now we quickly go through the name of experiment, right? So basically, uh, for the processing and all this operation, to perform the various operations, we are using the two software, right? The two software there we are using. The first software is the MATLAB. The first software is the MATLAB, and the second software that we are going to use is a LabVIEW. Now it is up to see once basically our college will start, so we'll explore it more. But meanwhile, my MATLAB and LabVIEW both are installed in my PC, right? So it is if somebody is coming to the college, they can collect from me and they can share with the students by Google Drive and something else. But whatever the experiments I will cover is basically covered by using this both the softwares, the MATLAB and LabVIEW. This software, right? MATLAB software and LabVIEW software. And I think you have prior exposures of one or two both the softwares. And if you don't have a prior exposure, don't worry, we will start from a very scratch. So that we learn about the first experiment is to learn about the various experiments of a MATLAB. Then we will generate the basic signals using a MATLAB, especially impulse signals, unit step signal, ramp signal, and sigma functions. Then we generate some other complex signal like as a sine, cosine, sinc function, triangular function, exponential, sawtooth, and rectangular using this. Then in fourth experiment, we check the various property like as a linearity, stability, time invariability using this one, right? Then at a later stage, we will learn the convolution operation. So experiment number 5 is regarding the convolution operations. Then we learn about the Fourier series and Fourier transform using MATLAB and LabVIEW, and study about the various Fourier series will be studied in experiment number 6, and Fourier transform will be studied in experiment number 7. We study the correlation and autocorrelation function in experiment number 8. Then we study the LabVIEW toolbox for a signal construction, especially for noise, how the filters are used in a LabVIEW. So we can have exposures of a LabVIEW in experiment number 9. 10 is regarding the Z transform, the sampling. We learn about the samplings using the MATLAB. And there is open-ended problems in which I give you a one project, small project, not a project basically, it's a problem, a small problem, and or in which you have to capture the real-time signal, process the data by using either LabVIEW or MATLAB, and then produce the meaningful outcome, right? Produce a meaningful outcome. So this is all from my side, and now I came back to the original screen, so for a further discussion. So this is all regarding the class teaching, especially from theoretical perspective as well as from a laboratory perspective. Now, from this device, I cannot take your presence, so I will connect with my desktop. And then, if you have any doubt regarding the subjects and anything, so we will discuss over there. So I am disconnecting from this device and connect with my desktop, right? So where we have a attendance and a discussion regarding the question answering and discussion regarding the lectures which I have conducted today. Okay. Okay. Is it audible? Hello.
Yes, sir.
Yes, sir.
Okay. So now this is what about the lectures. I have conducted the lecture, the first lecture we have conducted regarding the signal and system. So if you have any doubts that you can ask me by using this platform.
No doubt, sir. Not up till now.
Okay. So let me wait, huh? I just to take your presence. Okay, one more thing. This signal and systems you are learning with a pool of energy, right? And the another thing is that if you once this subject will start right in a regular fashion, and the chapters by chapters will be covered. Some students are preparing for a gate examinations, right? I encourage the students, those who are preparing for gate examinations, and if you found some problems regarding the in gate papers or in preparations of the gate materials, if you found some problems relevant to this subject, right, relevant to this subject, signal and system. So we openly discuss, right? And meanwhile, if you have any doubts also regarding any questions, you can personally meet me or you can send the message to me, that I am very much open to solve those questions, right, regarding this subject. So later stage, if this thing will happens, that without any hesitation you can consult me, if any clarity is required at any stage of the subject's learning, as well as the gate examination preparation or preparation of some other materials, then definitely the fully support will be provided from my side. Okay, so I think have a nice time and have a good day to all of you. We conclude this session over here, so you can join the next sessions. Okay, good day.
Thank you,
Thank you,
sir.
sir.